A $30 million contract was just awarded to Lockheed Martin and Raytheon to develop ground systems for the Space Force's Evolved Strategic Satcom program. The European Space Agency is making big investments into nuclear propulsion, and NASA just unlocked a process to turn lunar dust into oxygen. All this and more on today's Space Brief. Hello and welcome to the Undiscovered Country. I'm your host, Bryant A.M. Baker. Today I'll present the top 5 most important things happening in the world of space. The easiest way to support what we do here is to go ahead and hit the like button below. Let's get started.
Number 5.
The U.S. Space Force has awarded $30 million contracts to both Lockheed Martin and Raytheon to develop competing ground systems for the Evolved Strategic Satcom, or ESS program. The ESS is a classified SATCOM system designed to operate in the event of a nuclear war, and is part of the nation's nuclear communications architecture. The ESS program is aimed at augmenting and eventually replacing the current Advanced Extremely High Frequency Network, or AEHF, of nuclear-hardened geostationary satellites made by Lockheed Martin. Northrop Grumman developed the AEHF XDR payload, and Boeing and Northrop Grumman are currently developing competing satellite designs for the program. Lockheed Martin's team includes Stratagem Integrity Communications Solutions, Infinity, and BAE Systems, while Raytheon's team includes Dell, Seed Innovations, Infinity, Kratos, Northrop Grumman, as well as a handful of others. Both companies will have 18 months to demonstrate their prototypes before the Space Systems Command selects one for further development. The Pentagon plans to spend $6.5 billion on the ESS program over the next 5 years. This development is crucial as it ensures that the U.S. military can communicate effectively even in the event of a nuclear attack. The development of the ESS program will improve the reliability and resilience of the U.S. national security communications. But what are your thoughts on the competition between Lockheed Martin and Raytheon? Do you believe that this program will strengthen the U.S. national security? Let me know in the comments.
Number 4.
The European Space Agency is investing in research to explore the use of nuclear propulsion for deep space exploration. One of the studies the ESA is funding is being led by scientists from the University of Prague, the University of Stuttgart, and engineers from OHB Czech Space and OHB System in Bremen. The project, called the Preliminary European Recon on Nuclear Electric Propulsion for Space Applications, or Rocket Roll, will explore the possibilities of using nuclear fuel for demanding space logistics and exploration missions. Nuclear propulsion can be more efficient than chemical propulsion for solar-limited electric propulsion, enabling exploration of places no other technology can reach. New methods of power and propulsion are essential as humanity aims towards more sustainable space missions, habitats, and bases on the moon and beyond, which require the development of equipment and supplies. The study will also develop a conceptual design of a nuclear electric propulsion engine while considering the safety constraints of an NEP system from the early stages of the design. When the results of the rocket roll are delivered next year, they could form the basis of further ESA programs that look at the feasibility of NEP spacecraft that could be operational by 2035, if all goes according to plan. NASA is also studying the use of nuclear rockets and is partnering with the Pentagon's Defense Advanced Research Projects Agency, or DARPA, to develop a nuclear thermal engine and fly in an in-space demonstration as early as 2027. What are your thoughts on the use of nuclear propulsion for deep space exploration? Share in the comment section below.
Number 3.
NASA has successfully produced oxygen using simulated lunar soil in a vacuum. The test involved melting moon dust in a special reactor that can reach very high temperatures. The team detected carbon monoxide being released from the soil, from which oxygen can then be separated. The capability to produce oxygen directly on the moon is crucial to support the agency's plans for a long-term lunar outpost as part of the Artemis program. JSC senior engineer Aaron Paz praised the success, saying this technology has the potential to produce several times its own weight in oxygen per year on the lunar surface, which will enable a sustained human presence and lunar economy. The test was conducted by NASA's Carbothermal Reduction Demonstration Team, or CARD, using JSC's Dirty Thermal Vacuum Chamber to simulate lunar conditions. A high-powered laser was used to simulate concentrated sunlight to melt the simulated regolith, or powdery moon dust, in a process known as carbothermal reduction. The successful test certifies the technology at a level 6 on NASA's Technical Readiness Standards scale, which means the technology is ready for use during NASA's Artemis missions. The successful extraction of oxygen from lunar regolith has many applications, including the production of breathable oxygen and even rocket fuel. The ability to produce oxygen directly on the moon will reduce the cost of space travel by enabling a sustained human presence and lunar economy. It also opens the possibility of humans colonizing other planets such as Mars. What are your thoughts on this exciting development in space exploration?
Number 2.
NASA has named Emily Nelson as its new Chief Flight Director. In this role, Nelson leads the group that directs human spaceflight missions from the Mission Control Center at the agency's Johnson Space Center in Houston. She manages 31 active flight directors and flight directors in training who oversee a variety of human spaceflight missions involving the International Space Station and Artemis missions to the Moon. Nelson has been with NASA since 1998, when she started as a flight controller in the space station's Thermal Operations Group. She became a flight director in 2007 and has since led several missions, including the station's fourth utilization and logistics flight with the Space Shuttle Atlantis in 2010. She also served as the Deputy Chief Flight Director and has been acting as the Chief Flight Director since Holly Riding's departure in 2022. NASA's Director of Flight Operations, Norm Knight, said Emily's tenure leading our flight control teams has proven that she is remarkably knowledgeable on the realities of human spaceflight and eminently composed when facing daunting challenges. The Chief Flight Director plays a crucial role in ensuring the safety and success of human spaceflight missions. Nelson's appointment comes at a pivotal time for NASA as they prepare to push the boundaries of human spaceflight exploration and commercialize low Earth orbit.
Number 1.
NASA's Artemis II mission, the first crewed mission under the Artemis program, is set to begin training for the mission in June 2023, around the same time as the mission integration review. This mission is a lunar flyby mission and will use the SLS Block 1 rocket to launch the Orion spacecraft with a crew of 4 into high Earth orbit. The apogee of the second high Earth orbit will go out to the Moon, making a single flyby before returning to Earth approximately 10 days after liftoff. This mission is set to launch at the end of 2024, and NASA has locked down the mission requirements and is preparing for the mission. Matt Ramsey, NASA's Artemis II mission manager, said in an April 7th interview with NASA Spaceflight that we've kind of locked the mission down. You're trying to hone in on what the mission solution really looks like, and we're to the point now where we can kind of draw a line in the sand and say, here are the mission requirements, and we're going to start preparing all of these products that we're going to need for Artemis II. So it's the mission prep phase. NASA has also made some changes from the Artemis I mission, which was uncrewed, such as removing daylight constraints for launch and recovery and increasing the capacity for liquid hydrogen storage. The mission has a similar launch opportunity pattern as Artemis I, with alternating 2-week periods of launch opportunities and no opportunities. While the first human flight around the moon in over 50 years is a huge accomplishment, I'm interested in what you think the chances are of a smooth buildup and mission execution. Be a part of the conversation and let me know in the comments. Thank you for joining me. Links to all the stories are in the description. If you feel like this information has been helpful for you, please consider giving it a like or a rating and subscribing and following the content. I am honored to be a part of this community of citizens in this undiscovered country of ours, and I'll see you again next time.